Before we talk about the different storages and energy flows that exist in the mesocosm, we first need to identify what kind of system this mesocosm is. Since only energy in the form of light and heat is exchanged in and out from the boundaries of this mesocosm, we can identify this mesocosm as a closed system, which is contrasted to an open system where both matter and energy is exchanged. However, this mesocosm cannot be classified as an isolated system where both energy and mass cannot be exchanged in and out of the mesocosm. Also, since the various components such as the energy flow and storage of the system is on constant motion and fluctuation, establishing a equilibrium, which we can conclude that this system can be identified as a steady state equilibrium system as well. Now, to get into the specific energy flows, storages, negative feedback mechanisms, and positive feedback mechanisms, we can start with the initial point of energy transfer, which is transfer and transformation of sunlight into heat and chemical energy. As sunlight reaches the mesocosm and enters through its transparent glass, some of the sunlight is reflected. Most of them are lost as heat, and a small component of it are captured by chlorophylls and transformed into chemical energy in the form of organic matter, also known as primary vegetation. As a plant goes through photosynthesis, it uses carbon dioxide inside the mesocosm to synthesize its foundational blocks of life, such as glucose, cellulose, and etc., and releases oxygen and water into its atmosphere. Also, since the plant respire and transpire, carbon dioxide and water is emitted into its atmosphere and oxygen is taken in. This, as a result, forms an indefinite cycle where matter, such as CO2, O2, water vapor, is constantly flowing from the plant's biomass into the atmosphere and the atmosphere. The negative feedback exists in this way. For example, if the water vapor, carbon dioxide, oxygen concentrations in the atmosphere vastly increases, there will be a negative feedback mechanism in which the biomass of the plants increased in photosynthesis rate, thereby nullifying the increase in water vapor and carbon dioxide and oxygen concentration in the atmosphere. Another indefinite equilibrium system cycle exists in the mesocosm as well, which is underneath the plants in the soil. In the soil, when parts of the plant fall out and decompose and get decomposed and reaches the soil, and then are in contact with decomposing bacteria, it starts the gradual process of decomposing, whereby the large uh, macro macro compounds of the plants are decomposed into smaller nutrients such as nitrates and phosphates and etc. by decomposing bacteria. These nutrients are stored in the soil, which then eventually is which is absorbed into the plant by the plant's roots. Thereby, and then when the nutrients are absorbed by the plants, and when the plants die, these nutrients go back into the soil through decomposing bacteria. This indefinite cycle continues on and continues on unless its source of energy, which is the biomass of the plant, ceases to exist. Also, another tiny indefinite cycle, a system cycle, exists besides the soil and atmosphere system, which is the insect life. When tiny insects in this mesocosm dies, it dies after reproduction. Its bodies are decomposed into simpler nutrients and are fed to decomposers. And when the larvae of these insects are growing, these small larvae would feed on these decomposing bacteria and feed on the nutrients that these decomposing bacteria create, and thereby creating more insects. These insects, this also creates an indefinite cycle where insects die and nutrients increase in the soil and insects grow again from insects larvae. These three indefinite cycles of life in this mesocosm are ultimately propelled by a unique source of energy, which is the sunlight. Without sunlight, there will be no photosynthesis, and without photosynthesis, there will be no biomass that will enrich the soil and thereby enrich the plants again, and enrich the decomposing bacteria, and also enrich the insects who feed on these decomposing bacteria. Thank you.